Now, can you see my screen now?
Yes, sir.
Okay, let's continue from where we left off. The internet was messing me up. So as I was saying, some of clockwise movements equals anti-clockwise movements. Now these are the clockwise movements, the purple ones, the tennis colors. So if y is eliminated or is absent, these forces will pull the beam downwards in a clockwise direction. Now let's look for the anti-clockwise direction. Let's look for the anti-clockwise direction. I don't know if the streaming is still doing working. I'm trying the thing mess up. Okay. Let's continue. Okay. So now the anti-clockwise direction is we are looking for the forces that will move in this direction. So this force, the 10 newtons will move in this direction. If this is x, to move in this direction. So that means it's an anti-clock, right? This one, let me use a blue. It will move like this, right? And the y here too will move like this, right?
Yes, sir.
So see that if this is a pivot or a seesaw, this one will move downwards, the 10 newtons will move downwards, and it is moving in the anti-clock direction, right? Same as the arrow also moving in an anti-clock direction because of the direction, the arrow there, right? So those are the anti-clockwise movements. So what's the distance between the 10 and the x is 10 what meters. This is 10 newtons plus the x and the what r sub y. The distance between 10 and the x and the r sub y, this is the x. So r sub y is 20 plus 15, which is 35. So 35. Okay, so at this level, please, any questions? If you solve the problem.
Sir, we got what?
No, I can't even find my listing. So here's 35. How did we get the 35? You have to add the distances here. These distances. This one. And this one. Distance between x and the what? R sub y. Now, we didn't consider this force because at that point, there's no distance to the pivot of x. So it's a zero moment. Force times perpendicular distance. We have the force, but the distance is zero. So the moment over there is zero. That's why we don't consider that one. So let's continue. The rest becomes simultaneous equations. So this becomes 20 times 20, which is 40, plus 50 times. Let me write the 20 times 20. Because I didn't teach you. So 20 times 20 plus 50 times 15. Should we go to 10 times 10 plus 35 r sub y? The only thing is I make r sub y the subject. Are we okay? The YouTube is not working. Oh, Charlie. It's not working. That's why internet break here I have you. I'm gonna record it. After that maybe I'll post it. My machine I have to buy a new one. Because whenever I do this thing it still drains the machine. So this becomes 40 plus 750 equals 100 plus 35 R sub y. Right, so just make this one the subject. 40, sorry, 400. Oh, Charlie. 400. Nothing is working. Charlie, today dear, yeah, wow. To go and buy some correct i7 machine. We cry i7, but still me much. 400 plus 750. Can you see my screen? I don't know what is wrong with the Google Meet. Guys, can you see my screen? Today the network is really giving me a tough challenge. Can you all see my screen now? Hello.
Yes, sir, we can see now.
Machine is slow. 400 plus 750.
Before you went, we didn't get the part. You wrote the 20 to bracket 20 plus 50 bracket 15.
You are just multiplying force and distance, force and distance, force and distance.
Ah, okay. Okay.
I have to delete this one. The way I mean today's class, say I go deliver no way the internet the mafia man. Today so 20 times 20 times 20 plus 50 times 15 plus 10 times 10 plus 35 R1. You just make R1 the subject. So 400 plus 750 equals 135 R1. So 4, 7, 8, 9, 10, 11, 1150 minus 100 equals 35 R1. Hey, are you with me? Hello?
Yes, sir, we are here.
Okay. So 1150 minus 100. You get 1050. 1050 divided by 35. So 10 50 over 35 equals R1. Oh, R1, boy. This is 30. Can we put the value of that here? So R sub x plus 30 equals 45. R sub x equals 45 minus 30. R sub x is what? 15. Therefore, the reaction at x is 15 newtons. And the reaction at y is 30 newtons. Are we okay?
Yes, sir.
Okay. You can copy it. I'll share the PDF in the page. Intro. If you are done, then you notify me. Right, if you are done, just notify me so that we'll do another question. Are you done copying? Hello?
Yes, sir.
You're done, eh?
Yes, sir.
So next question. Let me take another question. Let's see. I remember here is slow. You said they have to buy a gaming machine so that when I'm doing a streaming, I won't find difficulty. I have some gaming machine right here. Now, my documents are not on that machine. One moment, please. I'll connect my. Live streaming, no be video. solve another question. Do you have exams questions that are in this lecture so that we can do them? Let me see if I can. Okay, let's do this one. So I have kilograms attached to it. Oh, Charlie snipping to come here. Let's do this one. Example 5. The question is not complete, so I'm going to complete it. Question with me. Okay, so let's do this one. A uniform beam of weight in 20 newtons, a length 60 centimeters is supported at 2 points x and y such that mx is 10 and xy is what? 15. The two forces 10 newtons and 15 newtons are placed at m and n respectively. If the system remains in equilibrium under the action of these forces, calculate the reactions at x and y. No, you see, it's a different question. No? This is the last question that we solved. Page. It's correct too, and the system remains in equilibrium. Sorry. I see that I copied the wrong question. Now let's solve this one. I hope you are with me.
No, sir. So it sounds like I'm the only one in the meeting, or?
Oh, only you. If it's only you, Crowd, you can do it.
Yes, sir.
I'm streaming via YouTube, so later on they can go and watch. Just give me the responses. I had issues initially. So a uniform beam XY of length 6 meters. So from here to here. So our drawing is ready. Straight like you can. Maybe a line. If I write it on my writing pad, let me use the shapes. Okay. So a uniform beam of What? X. Challenge. I'm writing, it's not coming. So this is X. This is Y. Are we okay? A length 6 meters. So from here to here is 6. Let me just repeat this one. It should be a line. Now, this is the distance, 6 meters. Then the middle one will become this thing. The weight of what? Now, a uniform beam XY of length 6 meters. This one you divide the 6 into 2. You're getting 3 and mass n kilograms. Now, weight is mass times what? Gravity. So the mass is what? N times 10. So 10 and don't let this confuse you with 10 newtons. So I don't know how to write this, but I don't want it to write it in newtons. Which means in the small letter n. Then later we come and substitute the values.
Okay.
Otherwise it will confuse you that is actually this thing in newtons. Oh, crowd me. And then yeah, wow, a lot of things are not working. So 10. Oh, sorry. 10n. I don't know what's wrong with my machine. Writing that thing is not coming. This is not coming. The pen is not coming. Today there are a lot of this thing.